Today we are exploring application security in the age of AI. Not long ago, software development followed a predictable rhythm: plan, code, test, deploy. But AI has upended that cadence. It's not just another tool in the toolbox, it's reshaping the entire attack surface. This new paradigm is AI-driven and fundamentally different. Traditional controls often miss the non-deterministic behavior AI introduces, so we must rethink how we build, secure, and trust our applications. Welcome everyone, let's dive into the critical shift taking place. Here's what we'll cover. First, we'll map out the new risks introduced by AI in the software development lifecycle. Next, we'll examine prompt injection, a subtle yet powerful exploit that targets the way large language models process input. We'll then look at the model supply chain, including how third-party and open-source models influence our security posture. Finally, we'll discuss behavioral defenses, new approaches to detect and contain AI-driven threats. I'm Ujjwal Sinha, and I've spent years in application security and bug bounty hunting. I'm excited to share insights that will help you future-proof your SDLC. Let's start at the very beginning, requirements. In the past, we focused on functional requirements and non-functional security, documenting what the software should do and how it should be protected. With AI, we must go further. The AI layer introduces probabilistic behavior, meaning our systems can respond in unexpected ways. We need to define boundaries for acceptable AI behavior and plan for failure modes. Ask yourself, what happens if AI hallucinates business logic? Without clear rollback paths, the consequences could be severe. So at this phase, security isn't just about writing requirements. It's about envisioning and constraining AI's potential. Moving into design, our threat models must evolve. Historically, we drew data flow diagrams and considered standard threats. But now we are dealing with large language models, LLMs, that can produce non-deterministic outputs and even act as agents. We need AI threat modeling that includes boundaries for model behavior and safeguards against data poisoning. Supply chain integrity now means verifying not only code dependencies, but also the models and training data we consume. When AI changes the code path, model integrity becomes application integrity. Designing with these realities in mind is how we build resilient systems. The development phase is where AI's disruption is most visible. Search trends tell the story. People are asking about AI-generated code vulnerabilities, LLM security risks, and co-pilot issues. As developers lean on AI-assisted coding, the volume of code grows, and so do the bugs. We see copy and paste amplification, where insecure patterns multiply. There's the risk of hard-coded secrets, tokens inadvertently embedded in prompts or code. And there's training contamination, where sensitive data leaks into models. To address these, we need updated controls. AI-aware static analysis tools, prompt scanning and output linting, dependency reachability analysis, and secure coding guardrails within our IDEs. It's about building security into the tooling that developers actually use. Testing must adapt. The traditional stack, SAST, DAST, IAST, still matters, but it's not sufficient. AI systems behave unpredictably. Static lists of vulnerabilities don't tell us whether an AI will hallucinate or misinterpret context. We need AI-updated testing, including dynamic simulation of adversarial prompts and verification of non-deterministic model behavior. This requires a shift in mindset, prioritizing exploitable paths over long CVE lists and validating real impact rather than theoretical weaknesses. The goal is to see how the system behaves under pressure and whether the AI can be manipulated in ways that matter. When we deploy AI-enabled software, the supply chain extends beyond traditional packages. Industry terms like SBOM, Software Bill of Materials, and PBOM, Pipeline Bill of Materials, are being joined by MBOM, Model Bill of Materials, and provenance standards such as SLSA. We must track not only code and dependencies, but also the models, datasets, and weights that our applications rely on. Establishing trust means verifying the origin of models, monitoring for tampering, and ensuring that updates don't introduce poisoned models. Think of it as an evolving supply chain where AI has a prominent seat at the table. In production, static findings and simple web application firewalls can't keep up. AI systems can be jailbroken through cleverly crafted prompts, and hallucinations can lead to business logic failures. That's why we need behavioral defense, techniques that monitor context and intent in real time. Telemetry becomes king. Instead of relying solely on predetermined rules, we analyze patterns, detect anomalies, and contain suspicious behavior before it causes damage. This is a major shift. Security becomes an ongoing conversation with the system, adjusting as new threats emerge. Let's step back. AI didn't just add a tool, it changed the attack surface. We need a new SDLC loop that fully integrates AI considerations. The strategic question for every organization is, are you still building an AppSec program for deterministic software, or have you embraced the reality of probabilistic AI systems? Traditional software is rules-based, binary, and predictable. AI systems are context-driven, fuzzy, and adaptive. To protect them, our processes must be equally adaptive. That means looping through requirements, design, development, testing, deployment, and runtime with AI in mind, continuously. We've journeyed through each phase of the SDLC and seen how AI reshapes the security landscape. From defining safe behavior in requirements to deploying trusted models and defending against real-time threats, we're entering a world where probabilistic outcomes are the norm. Building secure software isn't just about writing code anymore. It's about orchestrating people, processes, and AI in harmony. Thank you for being part of this session. If you found these insights valuable, please subscribe to our channel, like this video, and share your questions or experiences in the comments. Together, we can build safer AI-assisted systems and stay ahead of evolving threats. Thanks for watching.